Okay, so our first student contestant is Eileen Moreno, who's a PhD student in biological sciences, and her thesis advisor is Professor Shelley Halpane.
This is Junior Seau, San Diego native and NFL Hall of Famer for his 20-plus years in the NFL, 13 of which he spent as a San Diego Charger. As a result of the repeated head trauma he endured in his profession, Junior suffered from chronic traumatic encephalopathy, known as CTE. CTE is a progressive disease of the brain that leads to dementia, memory loss, and depression. Junior Seau lost his battle with CTE, and in recent years we have discovered dozens of other players of high-impact sports also suffer from this disease. So what's happening to these players' brains? When the head experiences a trauma, the brain swells. This swelling restricts blood flow to the brain and limits the amount of oxygen being delivered to the individual neurons. This is a crisis for structures inside of our neurons called mitochondria. Mitochondria are responsible for making all the energy our brains need to function, but they require oxygen to do it. We can think of it as the same way a car requires gas to run. Mitochondria require oxygen to make energy. So when there is less oxygen, mitochondria produce less energy, and this can lead to cell death. We already know that damaged mitochondria are involved in the late-term responses to CTE, but we don't know what mitochondria are doing immediately after a head trauma, or how repeated head trauma can make this mitochondria damage worse and lead to CTE. My work is to understand exactly when and how mitochondria first start responding to a head trauma, and I've begun to do this using a live cell imaging approach. What you are looking at here are mitochondria inside of a living neuron that dramatically change shape when deprived of oxygen, similar to what happens in a head trauma. If you look once more and focus where the arrow is pointing, you'll see a long mitochondria structure changes into multiple fragmented spheres when deprived of oxygen. I am looking to investigate the exact mechanisms that regulate this shape change to see if I can connect it to less energy production and the development of CTE over time. It is our hope that if we can understand the earliest events that are going on in the immediate responses to a head trauma, that somehow we can connect it to the development of CTE over time. You can imagine this would be valuable in applications not only applicable to CTE, such as car crash patients, stroke patients, and other diseases that involve the brain. Hopefully one day we will be able to prevent this terrible disease to protect the brains of beloved players, but also the general population. Thank you.